Baxter. I'm a faculty member at Nashville State Community College, and I'm doing this brief presentation on how to solve compounding continuously interest problems. And we're just going to take a look at the algebraic solution in this recording. There will be another recording that you can view after this one, where I look at how to solve this type of problem using a couple of graphical approaches. So look for that other video once you've seen this one. The purpose of this video is to help you understand how to use the continuous compounding formula to solve problems involving continuous compounding of interest. And again, we're going to look at the algebraic approach. Okay, so here's a sample problem. Jeremiah invests $10,000 in an account that pays 4.5% interest, that is continuously. The question is, how long will it take for the account balance to reach $25,000? What is the key phrase in this problem? Can you pick it out? How do you know which formula to use? If you're saying this phrase here, compounded continuously, then you are correct. If a problem mentions that interest is compounded continuously, all right, so if it specifically says that, then you can know that you are supposed to use a particular formula, or if you want to call it a function, you can do so. But there is a particular formula that you can use to help you work with these types of problems. So let's take a look at that particular formula. So again, if you have a continuously compounding of interest, which is an example of exponential growth, by the way, you are allowed to use this particular function here. So let's take a look at this. Let's talk about these. Now, notice I've got two different ones written here. But these equations, these two equations actually represent the same equation. It's just different notation that's used in the different equations here, okay? The first one here, the P of t equals P sub 0 times e to the kt power. That notation is typically what's used if you're talking about exponential growth of populations. So you would typically see this notation used if you're talking about, rabbits, the population of rabbits, or the population of mice, or some other population, maybe the population of humans growing exponentially. You're going to use this notation here. If you're using financial related information, you typically will see the second equation used, and it's just simply because the A of t represents the account balance. Okay, so we use A for account balance. In the first equation, the P represents population. But notice they are exactly the same equation, though. So since we're using a financial related problem, we're going to be looking at this second equation. So let's make sure that you know what each of these items represents. First of all, the A of t symbol, that would be your dependent variable. That represents the account balance after some time t. All right, so this represents the account balance after some time t. Some people call this the future value of the account. So it's the value of your investment, if you will, after some time has gone by. Okay, so that's your A of t. On this side of the equation, we have P. P stands for principal. Some people refer to that as the present value. That would be the amount that you are investing today. All right, so that's today's value. And you multiply that by E raised to the R times T power. All right, so the R stands for your interest rate. Now, don't forget, interest rate is input into this function as a decimal, not as a percentage. All right. So usually in most problems, the interest rate is given to you as a percentage, but you actually want to change the percent to a decimal before you put that in there, okay? And then T represents time in years, okay? So the number of years that you're investing some amount of money, just put that number of years in for T right there. So let's take a look. So here's our sample problem again. And I'm going to actually switch my screens. So keep this problem in mind, but let me switch my screens just for a second. Give me just a moment while I do this. All right. So let me first of all write out the function that we were just looking at. All right, so we have A of t equals P times E to the RT power. And again, I'm writing that out because I have a problem that involves the continuous compounding of interest. So I know that I can use this very specific formula for this type of problem. And then I'm going to plug everything in that I know, and then I'm going to solve for time in this example because it's asking how long will it take, how much time will it take for the account balance to reach $25,000. So again, the A of t, that represents the future value. So the future value for this problem is 25,000. I'm looking for my account balance to reach 25,000. The P represents the initial investment, so that's your 10,000. All right, and that's being multiplied by E raised to the, and we're going to put in 0.045, 0.5 because that is 4.5% as a decimal, and then that's being multiplied by T. So there's everything plugged in, okay? So of course we don't know the time, so we left that as T, and we're going to solve for time. We're going to solve for the T. So we just need to isolate the T. The first thing I would say when dealing with this type of equation is, I would want to identify the fact that it is a exponential equation. You know that it's an exponential equation because the variable that you're trying to solve for, the T, is up there in the exponent. All right, so if the variable is up in the exponent, the equation is known as an exponential equation. And how you solve those is you have to use a logarithm. All right, so that's the whole purpose of us, or I'll say that's one purpose that we study logarithms, so that we can solve exponential equations. Okay, before we use a logarithm though, you always want to do whatever you need to isolate this base with its exponent. All right, so the base and the exponent stay glued together, but you want to isolate that. And so that means I want to get rid of the 10,000 that's being multiplied by that. All right, so of course, to get rid of the 10,000, I would need to divide both sides by 10,000. All right, and then of course the 10,000s will cancel out, and we're left with just E to the 0.045t. And then on the left side, I've got this 25,000 divided by 10,000. Okay. Now I'm going to use my calculator real quick, and I will show you this in just a moment. But you guys, how to reduce fractions on your, right? If you don't, I'm anxious to show you. I will do that in just a minute. But you can just type in the fraction. So type in this fraction right here. You can just type in 25,000 divided by 10,000. And then you can press math. So press the math key on your TI calculator and select fractions. So select that first option. Press enter a couple of times, and it will actually show you on the screen the reduced fraction. So that is equivalent to 5/2. All right. So any fractions, just go ahead and simplify those if you can, reduce them down. And that just makes everything simpler. Okay, so once you have that base exponent isolated together there, now we're going to take the natural logarithm of each side of the equation. Now, why do we need to take the natural logarithm? We would need to do that because the base is e. Okay, so this base right here with this exponent is e. Whenever you have a base of e and you're taking the logarithm, you must use the natural log because the natural log operates with a base of e. If the base was any other value besides e, then you could just use log, just use the regular logarithm. All right, but in this case, we are required to use the natural logarithm, okay? So make sure you take that of both sides. All right, and then as you've learned about in class, when you take the logarithm, what that allows us to do is we're allowed to take this exponent and bring it out front of this logarithm here. Let me get rid of these little marks. And you can rewrite this expression as a product. So you've got 0.045t times the natural log e. And then on the left, you've got natural log 5/2. All right. When you have natural log e, that cancels out. So this is something that you want to try to memorize or know how to find that natural log e just equals 1. Okay, so that just equals 1. So that's just going to cancel out. And so we have now 0.045t equals the natural of 5/2. The last thing I do to get t by itself, of course, is I need to now divide by 0.045 on both sides. Divide by 0.045. Of course, those cancel out. And I've got my t by itself, and that's what I'm trying to solve for. All right. Now, the only thing I need to do at this point is I've got to figure out what this is on the left side of the equation. Like, what is natural log of 5/2 divided by 0.045? There's really no way to know until I use my calculator. Okay, so let me switch my screens again. All right, and let me pull up my calculator. And let's just take a look. Okay, so here's the ln button down here. So I'll take natural log, and it opens parentheses automatically. I'm just going to type in 5 divided by 2, and then close my parentheses. Here's the parentheses. All right, and then that is divided by, that was over 0.045. And you hit enter to calculate that. And so it looks like the time that's required for the account balance to grow to $25,000 from $10,000 is approximately 20.36 years. 20.36 years. All right. So there is the answer to that particular problem. And that is the process that you would take for these types of problems algebraically. So you want to just take the logarithm and get this answer here. All right. Now I told you I would show you how to reduce fractions. So let me do that. If you need to reduce the fraction 25,000 over 10,000, like we had earlier, you just type that fraction in. So you say 25,000 divided by 10,000. And then you press this math key right here, and then just select that first option. So just hit enter to select that, and then enter again. And isn't that great? It sends you back the reduced fraction. So there it is, reduced 5/2. And that's what we used in the problem. All right, so let me just return back to my presentation and we'll close this video out. In the next video, we will look at how to solve this same sample problem just using graphical approaches. And I really want to encourage you to watch that video, because once you learn how to use the calculator to solve problems graphically, it really just expands your understanding of how the functions are working, and it just expands your tool belt so that you have more ways to solve different types of problems. So I really want to encourage you to understand how to solve this problem graphically. Okay, so I'll see you in the next video. Thanks for watching.